All right, welcome back. We are COMP1116, Game Programming 3, and this is Week 8, Part 1 of our broadcast and recording in the fall 2025 semester at Georgia. Let's talk about where we are right now. So we just finished our exam last time we were together, and most of you did very well. Like, I'll be honest with you, I'm very happy with what I've seen. For the most part, some things weren't completed. There's some people who weren't able to complete stuff, but that's a very few number of people compared to the people that did things and did everything well. So that's good. That feels, and even though you might think it's easy, imagine doing that exam with no training and not able to, understand how to put notes together and stuff. That was part of the exercise. So what are we doing this week? This week we're actually setting up a brand new project. It's a third-person perspective project that we're going to download, and what I want to do with it is go through how to convert everything step by step, all the input into C++. And why? Because this second half is going to include more C++ than normal, right? Than before. Why? Because now you've learned more about nodes and everything, and we're going to kind of delve deeper into when to convert, how to convert, what to look for, all that kind of stuff. I think that's the important part. So without further ado, let's download our template if you haven't done it already, right? So again, download it. It's here. It's on the same OneDrive that you've had before. I've gone ahead and done this. So if I look at my project, here's i7. So I've already done this part. I haven't started it off, and it's not a C++ project starting off. So if I double click on my U project here, and it'll tell me, do you want to change the version? I only have one version here. If you had another version on your machine, they would have some options like I showed you in the PowerPoint. But for me, I only have one version, right? So the first part is kind of converting your project to 5.54. This project was originally written in 5.44, so there's very few differences. Now there are some differences, 5.44 to 5.54, and we'll talk about them as we get there. But for the most part, you'll see very, very few things that'll stop you from doing what you need to do. Okay, so again, what I do before I put it up on DevOps, I'm going to do that right away, is test your project to make sure that it works. Okay, test it out. Make sure that the project works exactly how you expect it would work, right? And I'll go through it with you to make sure that you see everything and where everything is in a second. This is a bigger project, believe it or not. Well, it is and it isn't. I didn't include the city building part. The city building part added a lot to our last project. But there's some stuff in there that we're going to talk about. Some choices I made from everything from animations to buildings to whatever. And I'm going to probably get you guys to make other choices later on. All right, so first things first, I'm building my project. It's doing all the shaders, all that kind of stuff as normal. One thing I recommend you do is you go to Edit and Editor Preferences before you do anything, and make sure I like to have my Asset Editor open location to main window. Do that, and then press play to make sure that this project works. So you'll immediately see that I have a third-person perspective character. I'll talk about some of the issues. WASD to move, right? You can see that they can move slow. If you press the Shift button, they'll run, right? And they can jump. Okay, so you can see that happens. The jumping is weird, but we'll talk about why in a second. I've added some assets. I've added this building that I kind of put together and slapped together, really. It's not perfect, and I don't really care. It wasn't meant for that. But one thing I did do from a design perspective is I did place some items that the character would see way at the end there. Almost like from a design perspective. The light shines upon the items that they could pick up. See that? Without any kind of like, hey, pick up these items, kind of thing. So if I run over there, you can see that I have 3 items. They're not something you can interact with right now, but there is a shield, there is a sword, and there is a bow. Okay, those items do exist. And also I have some items that I have here on the walls. From a fire and torch perspective, that's there. There's a chest here. It's hard to see, but it is here. And some natural light that's coming in from outside. But for the most part, it's a very bare bones project. And it's really a test project for you and your character. This is something we're going to build on this semester and perhaps next, right, as we move into game engines 2. So before I talk about the project more, let's put this up on DevOps, like as is, you know, kind of thing. So again, what I would do is I'll go File, Save All, close off the project, and just like we did before, I'm just going to kick off my terminal. This is not a Git project yet, so I have to initialize it. So I'm going to do a git init. You should know these commands by now. Git add dot, and I'll keep going when it's ready. Git commit -m initial commit. So we'll do this first. And now I need to change the branch. So git branch -M main. So let's change the branch name. And then from there, I need steering instructions from DevOps. So I'm going to go here to DevOps. And then what I like to do is make a project like normal, right here. And you guys should know how to do all this because you did it already many times. So just going through the process here. Also allowing some people to catch up if they haven't done this yet. Uncheck README. Once I've done that, I get steering instructions, these remote stuff, and I'm going to copy them, go back to the terminal, and right-click and paste, which, if everything goes well, should allow me to push everything to DevOps. It's not a terrible, difficult process, but I recommend you do it now as part of what you need to do. So again, you should know how to do all this because you did it already. And as you can see, we're spiraling over 1.6 gigabytes so far and counting. Now you might be like, wait, we don't have a landscape. We don't have a city. We don't have nothing. How is this project so big? Let me tell you why, right? So it's a big project, and this is good because this is probably how big at least your project is going to be with your, the game that you're going to be making soon, right? All right, so I've done the DevOps part, and so far so good. If I refresh my repo here, you can see that it's here, in its fine glory. And I'm going to go back to the File Explorer and launch the project. Now I want to talk about the project a little bit first. Bear with me, I'm going to go through different parts of it, and I'll let you guys catch up for people who weren't able to get the DevOps stuff started yet. But let's do that now. All right, here we go. So a couple things. Let's start looking at the folders, right? So let's go blueprints first, actually. In the blueprints folder, we have the following folders. We have a character folder, a game mode folder, and an items folder. If we look at the character folder, I've organized things into an animations folder and a rigs folder. I also have a main character, BP_main character blueprint, and an ABP_main character, which is the animation blueprint related to the main character. So this is all the same stuff that you may have seen before to some degree. In the rigs folder, you have a couple of things. A CR, right? A control rig, which is an archer control rig, and an IK archer, an IK rig. That's inverse kinematics, right? So I'll explain what that does in a bit. Inside the animations folder, you're going to see that there is one animation, a blend space that is walk run, okay, and it's walk run unnamed, okay, or unarmed. Sorry, unarmed, and we'll talk about what that is. So it's one blend space that's in there. So that is what's in the character folder. In the blueprints game mode folder, you have a custom game mode. We have that, and in the blueprints items folder, I've included torch, which you can look at, as well as several weapons, okay. So there are things like daggers, swords, shields, maces, sickles, spears, and a bunch of other stuff. If you wanted to make a fantasy game, most of the weapons you might use are here, okay? So it's not like they're missing. And these are items that I got from the marketplace previously. I've also monkeyed with them a little bit. There is a base weapon blueprint that they all derive from. And that means if you modify the base weapon blueprint, all the other ones will be modified as well. Okay, so that's what I've done there. I also, under the item, have the torch, which is something that you could equip your character with as well eventually. Okay, so that is all of the blueprints. In the assets folder, now this is crazy. Okay, so let's take a look at this, right? Characters in the assets. I have a bunch of animations. Now, you can see here that I have 246 items. So there are 246 different animations that I've given you, right, for your stuff. Now, where does this come from? Okay, I didn't make all these animations myself. That's insane. So what I got them from is from Mixamo. So you guys should be familiar with Mixamo, yes? Right? So if you go to Mixamo, and it's Adobe, right? It's an Adobe product. You can log in. I recommend you make an Adobe, if you haven't got one already, an Adobe account. And when you do, what you're going to see with Mixamo is all these animations here. But what I wanted to show you is instead of you having to go and download characters as well as animations, I've done all the heavy lifting for you. So I've done all that work. All the animations, any character that might be reasonable and stuff has been downloaded. Well, all you need to do is retarget your, your character so that they work. Okay, if you choose another character. So we'll talk about that later on. But yeah, these are all where all the mocap stuff comes from. So this is very basic. Some of them are good animations, some of them are not so good, right? But that's okay. Maybe next semester we'll do more with mocap and you make your own, right? So that is where they come from. Okay, so they're all here, and I've kind of labeled them in a certain way. So for example, climbing top wall anim, right? Here's one, climbing top wall anim. So you can see that she climbs in the top wall. So now this is, what this has in it, which is interesting, is it moves, right? So some of the animations, what you want to do with them is you don't want to make them like this, okay? Because what this is, if you think about what this does, is it actually moves the character. In order for you to do this, you need to make something called a root motion animation, right? Where actually the character moves based on the animation itself, right? Typically what we do is we don't do root motion animations for movement and that kind of stuff. But here what we're doing is it allows us to to control everything here in the animation sequence, right? So there's that. Again, I'm just gonna look at some other random ones, like falling back death. So you can see that there's a falling back death kind of animation. Again, this is kind of interesting. And again, you can pick a lot of them. Anything from magic to greatsword walking. So imagine they have a greatsword in their hand. They're walking with a greatsword, or a two-handed weapon of some kind. All that stuff. So you can see there's like a ton of animations here to make your life easy. So why am I giving you all this? You might use this with your actual game. That's the answer, right? You can use, you might want to use this project as a base if you're doing a third-person perspective game. There's nothing wrong with it, or at least migrate all the animations from here into your project, because then you can just retarget them all, right? So if you want to do some climbing or some whatever, you've got everything here. You don't have to look for them or download them or anything else. I fixed them all so that they all work, and you can check these out. Not only did I do that for you, but I also gave you a bunch of different meshes. So here's a bunch of different meshes. There's the barbarian mesh. Here we go. Here's the barbarian mesh, right? So here we go, this barbarian. So you have this dude. There's also, if we go through here, there is Drake, right? Which is some kind of, clicking on the wrong thing, some kind of monster, right, or whatever. And a bunch of other ones here that I've given you that you can certainly look at. Skeletal mesh. Here's a fish person skeletal mesh, right? And many other ones. So if you wanted to make your own type of game, based out of this stuff, or even prototypes, so I wanted to take a look at what these look like. There's tons of them that you can use, and all you have to do is retarget the animation to the character. Each character has a skeleton. They're laid out similarly, but they're not perfect, and we'll talk about retargeting later. if you don't know how to do that already. Did you guys learn how to retarget yet? Easy, easy peasy, okay? With some minor adjustments. All right, so that is just a preview. You can continue to look at them all as well. I've also given you textures for all of them. They're all in the textures folder. Materials are all in the materials folder. They're nicely organized, the project. And then you also have not just characters, but also treasure. So I've given you things like some, let's talk about treasure. So you've got all this treasure, right, like here. So you've got different chests and clay pots and a bunch of other stuff here that this includes, as well as weapons. So here's all your weapons for all these. There's the bow and, torch and the arrow and a bunch of other ones, okay? So if I go to meshes, you can see that there's a bunch of interior props for weapons. They have those, as well as a bunch of other ones, okay? So tons and tons of them. I think it's kind of a good thing to go through them because again, I've added in, I've kind of meshed together different things from different packs to give this to you in order for you to have options and to save you some time, because you don't have a lot of time between now and next semester, right? So that's why I'm doing it. If you wanted to make this kind of game, I could have made this a military game and I could have downloaded a bunch of guns too, right? But at the end of the day, most of the weapons are, again, melee weapons or even some primitive, missile weapons like a ranged weapon like that bow, right? So, all right, so that's what I've given you. There's different maps for the weapons kit as well that they come with, treasure and effects. So for example, things like a highlight that we're going to use later on, different Niagara effects, for example, different kinds of ways of highlighting certain things. We'll talk about them. And again, they've come for different projects and different tutorials and that kind of stuff that I pulled in so that you have something that you're going to go with. The input folder has your input mapping context, which is a third-person perspective. TPP stands for third-person perspective. And then a bunch of actions that I've already defined for you. And then, of course, we have the one map, which is our test map we're going to start with. Questions around the structure of the project. I wanted to go with there. So we have a big project. We have enough stuff to play with. And this is really our playground. I've kind of created a playground for you guys to be able to delve into, take a look at it and stuff like that. So I think you're going to find that some of it's fun. And later on, like I said, there'll be other things, other little tasks and challenges for you to do. All right, but immediately, that's not what we're doing today. I want to show you that. And what we really want to do is, after you've compacted everything, I want to convert this input action stuff into C++. Okay, so I'm going to go slow. Like last time we did this, we did it fast, right? And I want to go slow and explain stuff to you so that you're a little bit more clear about how everything kind of knits together, right? So in a different way, a different perspective than last time, okay? So what I want to do is I want to go to the characters, right? And my blueprints, and I want to go to character, and I want to go open up my BP_main character blueprint. As you're going to see here, we have what we saw before, which is in the event begin play, we get the controller, and then we cast it. Okay, I'm going to ask you some questions now. You should know why. Why do I cast the controller into a player controller? Why do I need to do that? I know it's Thursday morning, 8 o'clock. People haven't had their coffee. Jay's game. Yeah, go.
Is it there's more than one player?
No. And this is a source of confusion. When you first learn Unreal Engine, you're like, why are we always casting, right? Okay, let's go back and think about what the character is. The character is a class that derives from what class? It's in a hierarchy, right? So it goes actor and then pawn and then character. So pawn is something that we can control, right? The pawn has a controller. And the pawn's controller has been enhanced, extended into a player controller. But we can't tell if this self object, right, is a pawn or a character. Right now, the get controller node gets the controller from the pawn, right? the superclass. So this controller gets the pawn's controller. That's what it is, right? It's a pawn. Remember, we have an is-a relationship between character and pawn. A character is a specialized version of a pawn. That's what it is, right? So therefore, we do have a controller here. But we need to cast it, and what we're really doing here is upcasting it, right? Downcasting it to, because we're going down the chain, right? To a player controller, because the player controller does exist, right? We have to change it. We have to basically say this is where we want to do, and we need to do that because the enhanced input local player subsystem, or the enhanced input system, is not available on the pawn controller. It's only available on the player controller. So if I was to try and do it from here, if I said something like, right out of here, if I said something like enhanced, right? You can see that it's not going to be there. It says enhanced input, but it says get enhanced input settings. That's a different thing, all right? Where we want to get this. This is basically a reference to the input local player subsystem, all right? That's where it comes from. Once we have this, then we have several methods that we have in our platform, and one of them is add mapping context. That is a method that exists. One thing else I want you to zoom in on this time, this second half, guys. Please read the messages that you get here, okay? Do not ignore the messages. Look what it says here. Adding a controller mapping target or context. Target is enhanced input subsystem interface. Cosmetic. This event is only for cosmetic non-gameplay actions. Okay, interesting, right? So that's what it is. There's a couple things here. A priority, right? And there's also some options that you can modify things with as well, right? So this is how we get a reference to the input mapping context. We don't really do anything, but once we've added the mapping context to the enhanced input local player subsystem, then all of our input events become available that we can use here. Even if you didn't do the mapping context, the input events would work, but they have nothing to map to. The mapping context binds all the input events to the character blueprint and activates them basically, okay? And then we have this get control rotation. Take a look what it says. Get the rotation of the controller, often the view rotation of this pawn. So what the pawn is looking at. Target is the pawn. Remember, character is a pawn, so therefore, in this context, it's the character, where the character is looking. Then get the right vector. Rotate the world right vector by the given rotation. Target is Kismet Math Library. Kismet Math Library is something that it's an old library. It's been around in Unreal Engine since way before UE4, right? And the Kismet Math Library is something we're going to tap into on the C++ side. But we have to do an include that says include Kismet. We're going to do that, okay? In order for us to get that. Then we have the add movement input. Add movement input. Well, the reason why we can do that here is because the character has a character movement component right here. Therefore, they have an add movement method. If I didn't have the character movement component, then the add movement input method would not exist. That's why it exists. Oh, we lost it again? All right, so that's what that is. Okay, I know I'm going slow here, and it might be boring to look at these nodes, but I want you to understand, and this is kind of the same thing, except for now we're looking at forward and back, the forward vector instead of the right vector. Same thing with add controller yaw input. All these inputs and stuff are part of the character movement component. There are two built-in jumping methods. One of them is jump, and the other one is stop jumping. And if I look at it, it says make the character jump on the next update. If you want your character to jump according to the time that the jump key is held, then you can set the jump hold max time to some non-zero value. Make sure in this case to call stop jumping when you want the jump's Z velocity to stop being applied. So there's some information here that exists that we just keep ignoring. Okay, so just letting you know, all right? And last but not least, I made them run. We didn't do this last time with our little first-person perspective game, right? We didn't make them run. By the way, that was an optional thing I was going to add to the test, right? Make your character run, because it was like, characters go really slow in that game, okay? How do you do it? Well, remember that we have a character movement, right? And character movement on the right, you can see it has a bunch of little things that are built in. Now, if you're comparing this to Unity, Unity has a character controller, which very similar things if you're going to compare it to Unity. right? But one of them is, if you scroll down, here's character movement walking, right? And we have something called max walk speed. And notice that it's set by default to 150. And so too is this, max walk speed. I've just set this up so it's the same. And then it jumps to 600. So I'm changing the walk speed of the character. Okay, cool. I'm also using the blend space. The blend space is interesting. Have you guys looked at blend spaces yet? You guys have? Let's take a look at that blend space. Let's take a look at that blend space. So if we go to the blend space for a second, I'm just going to copy this. So under the animations for the character, there's a blend space. Let's open that up. So what is a blend space? Well, it kind of looks like this. It's a graph, actually, right? And what we have is different points on the graph. So here we have a unarmed walk back anim, right? That's what that is. What you can do is if you take the control key, you can actually drag it to the left or right, depending on what you want, or backwards, and it will affect the animation that is played based on the speed. Let me explain something here so you get it. On the bottom of the graph is direction, where they're looking. On the side of the graph is speed, so it's speed versus direction. So that means if I take the control key and move it forward, I'm going pretty fast in a straight direction. If I go here, you can see I'm going to the left, and I go here, I'm going to the right, okay? I know it looks opposite, but actually this is to the right because look, we're looking at the character from the front, right? So we're moving to the right here. And then this is going backwards. So this is where I'm walking backwards here, okay? And this is how fast I'm going. So you can see that the animations are changing based on the speed automatically as opposed to doing something like this in programming. If my speed is this, then play this animation. If my direction is this, then play this animation. If my direction and speed is this, then play that animation. Why would we want to do that? Unity does this, by the way. Unity does, there's no blend space. You have to do an actual, like, you know, basically a graph, you know, and what you're doing there is you're creating almost like a visual about what happens when you change speed and direction and all that stuff. It's too much. And so Unreal's handled this by using a blend space, okay, instead of a state machine, which is what Unity uses. All right, so that's why I kind of like it, and that's what this does. So that's how everything works. Okay, so then where do I begin in doing this? Well, like I said to you, in the PowerPoint, it begins from the beginning by creating a C++ project. Let's do that. So on the left, I'm going to go to Tools, and I'm going to go to New C++ class. Okay, we want to make it of type character, and we want to make the name of the character main character. By the way, don't be upset because our blueprint is BP underscore main character. Main character and BP underscore main character has no clash. They're two different names. All right. If they were the same name, they would have a clash. Do not name things the same, exactly the same as your blueprint. Like if you name my class BP underscore main character, you might confuse Unreal Engine. Okay, don't do that. So I'm going to click here, create class. And just like normal, what you're going to see is when the class is being created, we're going to see that Visual Studio, it'll ask you to open up Visual Studio and all this kind of stuff like normal. Okay, again, it's all the same stuff we did. Tools, on the Tools menu. There we go. All right, and do you want to edit the code now? The answer is yes, always, and it'll open up Visual Studio. And then what we want to do here is clean up our class first and put this up on DevOps, okay? We want to have remember I have a commit right now, no C++. Now I want to make a commit, first C++. We just added C++ to the project. This way, worst case scenario, you can always revert back to the previous commit where we never had C++ and our project was working perfectly, right? Okay, so back to this now. So now that I'm here, I want to clean things up as normal. Let's get rid of this boilerplate comment stuff that's useless. I wish I could just like flip a switch and say I don't want any of this stuff, but you can't. Let's get rid of all this. Okay. Okay, that's the .cpp, and this is the .h. Here we go, get rid of all this. I also don't like the fact that we have more than one public area. I don't like that, so I usually get rid of it. That's just me, right? It's not like your project won't work. You can have as many public areas as you want, but I find that separating things into a public, a protected, and a private area is easier for me to maintain. Okay? It's not because I don't think it's useful to do two different ones, like having separate stuff that's built in. What they've done is they said, look, public for constructor, let's keep that separate because that's part of the constructor. And I'm like, yeah, but why? I don't need to do that. So I'm going to cut this stuff here and put this in here like we've done many times before. All right, so we even put these together, save some room. I like spaces between the areas, and I can get rid of the last one. Okay, there we go. So save. So now that I've saved everything, let's save all. Make sure that they saved all. Let's close down. Let's save all here and close down Unreal Engine. File, save all, right? And before we push things up to DevOps, I want to make sure that I can build from here into Unreal Engine. So I want to do that. So Control F5 after Unreal Engine's been closed, the editor, and I should be able to build my project, and it should open. Now, I'm on a school computer, so if it doesn't build, that's okay. It might mean that I need to build manually, and you should know how to do that by now too, right? Building manually, again, you get rid of the derived data cache saved binaries, folders and so on. And once we've done those two things, then we can regenerate the project files, and that would still do everything that we're doing here. It would just force build, right? A force build sometimes, my friends, is required. Okay, like there's going to be some times where just things don't work the way we want them to, and we need to force build. For now, though, it looks like we're all good to go, right? So this is all good. And by the way, context: last semester that we ran this project, right? The build would never build from Visual Studio. We always had to delete everything and do it over and over again from scratch. It was a real pain in the ass. So luckily, we don't have to do that. It asks you, do you want to open up the asset editor that was open before, previously to this? I think it's a good idea always to do that. So have a seat here and sit down as I'm still affected by all these vaccinations. All right, and yes. And now we know that we're good. We've kind of loaded everything up and we're good to go. Okay, let's close down File, Save All, right? Close down the editor again. And then go back into Visual Studio, and now let's populate everything up on DevOps. So again, View, Terminal. This is a great place to put this up on DevOps because we know it works now. And we'll do a git at dot, git commit -m, and we'll say added C++ to project, which we added a main character, but that's not, we haven't done anything yet. And git push. So what this does is it adds a source folder, and it creates all the stuff that we need for C++, and all that stuff. And I think it's a good thing to do to check mark when we move from blueprints to C++ for the first time, like I said, so we can backtrack. We can always go back to blueprints, right? As opposed to doing things with just C++. All right, well, I want to start converting, the conversion process. And I want to think about all the things I need, right? So a couple things. And now I'm going to do this in a different order than I did in the PowerPoint slightly. But I want to explain myself first. Remember, the enhanced input subsystem is not automatically added in to the C++ side. We need to add it as a module. Unreal Engine makes everything modular, right? And remember that there's an extra file here. Take a look here. Again, if you recall, there's an extra file here inside of your project and in here under source. And it's called, if you open up the project here again, it's called the TPP starter project build.cs, this file. This is actually a C# file. And you can see here that I have some dependencies that have already been included for us right here. Again, this is inside of this folder right here, okay? This folder. So and again, if you look at the PowerPoint, I also go through this, but I'll do it in a different order here, and I'll tell you why, right? Because I find that sometimes doing this first is better, because once I add this in, then I'm good to go. Remember that C++, C#, doesn't care about spaces. So you could do something like this, typically, and if it makes it easier for you to see, that's fine, right? What we want to do here is we've got some basic modules, and what I want to do is I want to add in the enhanced input. So I want to kind of do here, and if I press Control space, to kind of get some help. Sometimes you'll get help depending on the machine you're on, sometimes you won't, but really what we want to do here is add in a reference to enhanced input, okay? And this is the subsystem that we're talking about here. So if you look and see what we're doing here, we're actually having something called a dependency module names. And so this is the build system for Unreal Engine. It's really kind of cool. What it allows us to do is add things in here we want to activate instead of having our Unreal Engine's application being very large and fat. Imagine if you had every single plugin. Why? If you're not using it. What if you're not using water plugin and you have it in? Why would you do that? It's like huge. Our project is already huge, guys. It's already 2.4 gigabytes, right? Or 2.5 gigabytes. Why make it any larger than we have to? So that's what we're doing here, okay? Now, one thing to note, we have to build our project, okay? Really build our project. The way to do that is to go into, and this is sometimes fails, that's why I told you I'm gonna start from here. I wanna go into the build folder, and then on the top here, you can see build solution. It's also Control-Shift-B. Now, sometimes this fails, but you need to do it. So this build solution up here, right? And then if you do everything properly, if you've saved your build, it should build just fine, okay? What this does is it builds all the Unreal Engine editor, it rebuilds it again for us. It adds in that module into C++, okay? So it said build succeeded for me. It should say build succeeded for you, okay? This is a very important step. If you don't do this, bad things are happening to good people. And you won't it'll never work. You'll be like, I don't know why, Tom, but my enhanced input subsystem doesn't come up. Well, you didn't add it in, right? So, and that's one of the problems sometimes we run through a tutorial and we're like, AI is not working, or UMG is not working, or this is not working and that is not working. You didn't add it in, that's why. So that's the first step. Now that we've done this, run it again, Control-5. So again, why? Because we always want to make sure that the state of our project is running. So Control-F5, and we'll put this up on DevOps again. So another commit. Why? Because now we've added a module, and it's a big one. It's huge. Enhanced input subsystem is a huge module. And we want to make sure that it's working properly. I want to run the editor to make sure that we didn't break anything, okay? If it breaks here, that would be very bad if we tried to continue, because we would say, well, I don't know why it broke. Everything was working. No, it wasn't. You never tested this part, right? You need to test every time you make a big change like this. So back to this, we should run it. We're good. We can run. We can kind of jog. We can jump. We can change directions and all this stuff. Good. Excellent. File, save all, and close the editor, and view terminal, and make a commit. Git add dot, git commit -m, added enhanced input module, which is what we did, and git push, okay? So again, a little bit here, a little bit there. We're adding to everything, and we're doing it step by step so we can always step back. That is why. If you do it, or if you add stuff and then you're like, oh my God, I broke my build, right? And you're like, wait, what happened here? How come I broke? Well, you didn't do enough commits. And that is the bane of young developers like yourselves. You don't do enough commits, and then you're like, I'm stuck. It doesn't work. I don't know why. It broke. Can you revert? If you're using Git, you can revert. You can go back to the previous commit, right? So, all right. So now that we've got this, and we're good to go, we know this is working. Now we can add some stuff in here. For the sake of time, because I could hand slog everything if I wanted to, for the sake of time, I'm just going to go back into the PowerPoints. The first thing I want to do is forward declarations, and I have a list of them here for you. So if you go to the PowerPoint, you can copy paste this stuff one thing at a time. I want to explain what forward declarations are again. But I want to ask you the question first. What are forward declarations? Why do we need these ones? Why? Why even have this stuff? Why not just do a bunch of includes?
It has the C++ file when it's looking at.
Yes, but why not just include everything? Why not just do a bunch of includes? I mean, I could just do includes here, right? Include U input mapping context, include U input action, include F input action value, include U map, why don't I just include everything? Huh?
When the file gets too big.
Well, no, because I'm going to do it anyway later on, right? Remember, what a forward declaration is, my friends, is this. I promise, I so solemnly swear, almost like you have your hand up and on your hand, one hand on the Bible and the other hand like up, okay? And you're like this. I so solemnly swear that I'm going to declare this later, okay? C++, don't worry, I got this. That's what you're saying, okay? But why? Because imagine if tomorrow I want to make a subclass of my character superclass. Example, an enemy that works almost exactly like my character. Then guess what? They immediately will have every one of these things installed because they're going to use the .h file that they're going to inherit from. So the file order gets fat. It's almost like I become a problem, right? Like I create a problem. Also, it's hard to maintain because you don't know which ones you've included or not. You have to go up the hierarchy chain to figure it out. We did this in the person class. Remember, we did the person class and the student class? And I talked about forward declarations there too. You don't want to do that. It's a naive thing to think. Let's just include everything. No, let's forward declare everything and then we include them in the C++, the CPP file. That is the way we do it. All right, that's the first part. That's why we use forward declarations. Next, now that we have forward declarations, right, what we want to do is we want to add in the two overrides that are built in. Remember this jump and stop jumping? We want to add those in. So copy those and go and put them here inside the public section. So here, all right, jump and stop jumping. Notice there is a green underline. And the reason why is because we have declared them, but we never even though we declared jump and stop jumping, we didn't define what those functions are. We're not going to do that here. We're going to do that later. Okay, so one thing at a time. So we've added a couple functions. And notice that there's also no U function. Okay, here, let me talk about this again. Why U property, U function, U class? What do they do again? Let's talk about this one more time, because I think some people are still confused about that.
Do they tell the blueprints? Is it for the blueprints?
Uh-huh.
And it's like the POs and the side thing?
There's a thing that's called reflection. So what we're using is the reflection system. And the reflection system allows us to expose anything that we mark, annotate, with a macro U function, U property, U class, U enum, as an example. We expose those classes in blueprints for us to use. Okay, that's what we can do. Okay, so it's an interoperability. It's the ability for us to interoperate between C++ and Unreal Engine Editor, right? By adding these annotations. That's what they do. So the reflection system allows us to do one more thing: garbage collection. Remember that in C++, you have to do your own memory management and you have to do your own memory garbage collection. When you kill something, you have to clean it up. If not, you have a dangling pointer which can cause a memory leak, right? And so here, the reflection system does all that for you, and that's why it's highly recommended you use U property and all that stuff. Okay, next. Now that we have those two things, we need a bunch of properties. And what I've done is I've included them here again just to simply make it easier for us to copy paste. I will go through them though to explain this, okay? Just like we did before, we have all these properties. And here is an example of a property, U property, and I have edit anywhere, blueprint read write, and a category. Category is a nice filter for us. That's what it is. Edit anywhere, there's other options other than edit anywhere, okay? Some of them are visible anywhere, okay? You can see it, but you can't edit it, okay? Blueprint read write also has blueprint read only. So you can only read from a blueprint. You can't write to it, all right? And we can explore these another time, but what this does is it's the most generous when it comes to adding these things in, okay? So again, you can get these from the PowerPoint, and I put them in the protected section, okay? This is great. And notice what they have here. We have input actions and an input mapping context. Okay, why do I have these? Why do I have my input mapping context here and my input actions? Why do I even bother like this? Why do I have to add them in here? We never have to do this on the blueprint side. Why are we doing them in the C++ side? There is no binding, my friends. Right? We have to do that step, which is in the, we have to bind it manually ourselves. That's part of the thing that we're doing. And we can't bind them manually ourselves until we have our manual binding that we do on the blueprint side. Remember, we have to actually make those references ourselves manually on the blueprint side. If we don't, there's no way to connect, our blueprint with C++. Okay, so that's one thing. So now that we've added these properties, this is good. Let's keep going. The next part is we need to add in related functions. So I'm going to grab these functions. And I also consider these callbacks, right? Again, we didn't need to do this, but we could have, right? Here's our functions. We have a move function, a look function, an interact function, an attack function, a dodge function, a run function, and a stop running function, okay? But wait a minute, and on the Unreal Editor, we never had these. It was just directly on the IA move, IA look. Guess what? We could have had them. We just didn't. We put them directly into our editor, our event graph. Right here, we're breaking them down into little things like this. Do I need to do these functions like this? No. It just makes it very convenient. Okay, so that's what we're doing here. So first we declare all the functions. Lastly, what we want to do is we want to declare two private properties, one for the view camera and the other one for the camera boom, right? If you remember in our character, it already has a camera and it already has a camera boom. We're going to rewrite these. And I want to do this for two reasons. One, I want to show you how to add components in C++ manually yourself, right? As opposed to in the editor, right? That's what we're doing here. This is why I'm doing it. So again, I'm going to grab these lines of code, including the private declaration, and go back down here underneath this and put it here, like so, okay? So that's where this goes. All right, so we've got all of our properties, but we need to declare all of our methods, all of our functions. One of the ways to do that is if you go to here, and if you're using something like ReSharper, if I kind of pull this down, pull down the tool, you can say, like, there'll be an option that says create declaration definition, you know, kind of thing. Like if there might be another option other than this, right, as an example. But for us, what we have to do is do it manually. So we're going to start off with jump, and we're going to go to the screwdriver and click create the definition. And we're going to hop back and forth here. We're just going to do them each individually here. So again, click onto it once, go to the screwdriver, create definition, and scroll down to move, go to the screwdriver, create definition, and we're going to go to look, go to the screwdriver, create definition, and we'll do them for the rest. I won't keep saying that because I'm sure it's annoying you. It's annoying me. Again, if you had ReSharper, you can do this all at once. But I'm doing it like this just in case you don't. Some people don't have ReSharper for whatever reason. All right, so we've downloaded all. We've kind of defined everything. This is good. Save all. We're still not ready. Now we start with the constructor function. And in the constructor function, this is where we would define this new stuff that we're going to do. So back to the PowerPoint. I'm going to scroll down here, and you can see that in the constructor function, we already did this part. First of all, actually, before anything, in the CPP file, we want to do all these includes. So all of these includes in the CPP file, I've included them for you, so you don't have to search them out. That would be underneath the .h file here at the top. Make a space and add all those includes. This will allow us to do two things. One, test to see that our enhanced input subsystem is working. Notice that there is an underline here where it says cannot open source file enhanced input subsystems.h. This is a bad thing, my friends. That means my module did not build. That's what this means. It's an error. Do you have this error too? Yeah, right? This is a problem. So, and I'm saying this because if I go back here, enhanced input, even though I did this and it says press F6, in our case we just did a build, sometimes we need to do this manual build and it wouldn't work. So what I want to do now is before we continue, right, actually let's put the manual build in here. We haven't done anything. This is okay. We've got all of our definitions here. We haven't started to do anything. I want to do a manual build, and I'm going to do the manual build. Okay, so save all. I'm going to close down Visual Studio. Remember, this is how we do it. And I'm going to go back to here. And now, remember what I want to do? I want to get rid of the intermediate, saved, derived data cache, and the binaries folders. Intermediate, saved, derived data cache, and binaries. Delete them. Right? And what we want to do is here, I want to right click and I want to go to show more options and generate Visual Studio project files. This will do the build for us, my friends. This will do that whole build process. Sometimes we just have no choice, okay? We just need to do it this way, okay? Now, what if we get an error here? If it says, oh, you get an error, something's wrong, you know, whatever, like you guys got. I didn't get that error. Next, once I've got that done, then I want to double click so I can kind of choose to rebuild my project. This is going to rebuild my project next. So then I'm going to double click on this and rebuild my project. So this is going to rebuild Unreal Engine, the editor again. It's going to add in the binaries folder, and it should run. It should build everything properly. So this is the manual process. If your Visual Studio fails, again, the only reason why I could do this is this. I have all my includes. I've got all my files, my folders. I've satisfied the requirements, right? If I don't satisfy my requirements, you will not be able to do this process, all right? So again, I'll show you my Visual Studios to show you where I did it, right? Because otherwise, you're going to be like, wait, it didn't work for me, but it worked for you. But I did certain things. You've got to do what I did. So it rebuilt everything from scratch. That means some editor preferences are gone because we've destroyed the derived data cache. Once the save folder does that, right? Where we have some preferences, like for example, your layout, preferences, and things like your editor preferences up here, right? Where we had this starting off in your main window, that's got to come back in again. We have to kind of do all that because it was lost. File, save all, make sure that the project still runs the way it was before, and we want to, again, file, save all, and close Unreal Engine, and let's double click on my Visual Studio project again. And let's take a look at it, and what you should have now, if we did everything correctly, if we did things correctly, is no underlines. That's important. If we have underlines still, something is desperately wrong, and we're going to have a big issue this semester, right? No underlines so far. This is important. Wait for it though. See this? See how the enhanced input subsystem has no underlines? This is what we wanted. If afterwards we still have these underlines here, something is desperately wrong with your project. You will never run as long as you have underlines in here, okay? That means your include cannot find what you're looking for. And it can't find what you're looking for because the modules have never been added in properly. I cannot, express this enough, right? We're going to do this again later on. All right, now that we know everything's added in, another commit, please. View terminal, right? So we actually fixed the bug because it wasn't actually done. Git add dot, git commit -m will say fixed, enhanced input module add-in, right? We did that because something was wrong. Like we can clearly see there was an issue, right? I wanted to show you this process because, people run into this. Programmers starting off with Unreal Engine for the first time, they look at it and they're like, I just can't get it. I don't know how I can do this. And by the way, I was one of those people. When I first started using Unreal Engine, I was like, what the hell is wrong? Like, why isn't Visual Studio working properly? Why isn't this? Why isn't that? I was breaking my brains, my friends, trying to figure out. And and I'm not joking around, weeks of trying to figure it out, I figured out how stupidly easy it is to figure it out. Through going through forums, because at the time there was no ChatGPT, right? Talking to other programmers, right? And all this kind of stuff, looking at videos on YouTube. Finally, I figured it out, and it took a long time for me to do, right? Now, of course, we know how to do it, and it's no problem. All right, so now that I've got this, let's continue with our project. So I'm going to close this down. So I'm going to go here, and we've got this, I'm going to go to this part and add in all this inside of the constructor function. I'll discuss it now. So what am I doing here? So first of all, I'm going to use controller rotation yaw is false. I'm going to turn that off. And then here we go. When I want to add a camera, I want to do something called create default subobject. Create default subobject in your mind, if you want to relate it to Unity, is this: instantiate. That's what I'm doing. Okay, I'm doing an instantiation. Okay, I'm creating a component called of type. That's what the angle brackets mean. Of type use spring arm component. And in editor, it's going to say camera boom. That's what it's going to be called in editor. That's why the text is here. Okay, I'm changing the target arm length to 400. And I'm also using something called use pawn control rotation is true. I'm checking all these things off. Then there is a setup attachment. You have to add this in to your components. Remember that by default, my friends, you have a root component. The root component of your project has already been defined for you. And what we want to do is we want to connect our camera to the root component. Next, I want to instantiate or create a default subobject of U camera component. So one is the spring arm, then there is the U camera component, which is a subobject of the spring arm. I'm attaching it. The setup attachment here isn't to the root component, but rather to the spring arm itself. So the spring arm is the parent and the camera is the child. That's how we do it, okay? And that's what this part is. Next, we're going to go to the begin play. Begin play is where we do all the binding. This is the binding of our input mapping context. Please make sure you do it in the begin play and not somewhere else. When I was prepping for this for you guys, I erroneously put it in the tick function. That would be very bad. Okay, don't put it in there. It's got to be in here. So let's take a look at this. Hey, look what I'm doing here. I'm casting my player controller. That's what that is. I'm casting my player controller as my controller as a player controller. I'm doing the exact same thing we did in Blueprints, but I'm doing it here. I'm saving it as a reference and I'm calling it player controller. That's what I'm making this. So I test as if this is true. If I can cast, that's what this line means. If I can cast my controller to a player controller, check mark, good. Then check to see if I can get the enhanced input local player subsystem. If I can, then get the subsystem. I'm going to use the player controller get local player, right? And I call this reference subsystem. From the subsystem, we didn't have to do this in Blueprints. We just did directly from the subsystem. We created our own mapping. But here I'm just having an extra step, right? I'm kind of declaring the subsystem and here I'm using it, right? So subsystem, add mapping context, and I'm using the TPP context. I define this over here, right? Inside of my protected section right here. Here's my TPP context. Again, this refers to the asset in the blueprints, on the blueprint side. The asset, which is your TPP underscore IMC. That is the asset. We don't have this asset yet because we haven't made that connection on the blueprint side, but we're prepping for it now, okay? Back to this. So now that we have this, yay, we have our begin play. Let's continue moving through every part of the way. Here is where we do our binding. So I'm going to grab all this code and I'm going to bind this. Now, in Blueprints, we never had to do this, right? We never had to do this manual binding. We're doing manual binding here because we don't have any references to the input actions at all here in C++. C++ knows nothing about those assets at all, right? By the way, one aside is I could make it available to C++ if I wanted to. I could kind of go directly and look inside of a specific folder and blah, blah, blah. Why would I not want to do that?
Sounds complicated.
No. So imagine if I gave you a path to the folder for your asset. I said something like, okay, C++, look inside the input folder, look inside the the actions folder, and inside there you're going to find an asset that says this, and get that and map it instead of doing it this way. Why would that be bad?
If something changes.
If something changes, if you move around your folders, everything is broken. It's a dumb way of doing things. Don't do it, okay? Let your artists and your programmers assign things. That's why this is a much better way of doing it, okay? Next, for the jump and the stop jumping, we just want to use the parent. So I want to do something like super, right? Jump. So it already exists. We're just going to use the super superclass method jump. Same thing with stop jumping. So super, and then it's stop jumping. Okay? Move function and look functions. Okay, let's take a look at the move function next. The move function is here, and just like we did before, here I'm looking at the character's look direction. That's what this is. I'm saying, first of all, get a movement vector. That comes from the value, right? It's a 2D vector, x and y, right? Where x is on the xy plane, left and right, and y is on the y plane, forward and back. That's what this is. So it gives me a vector, okay? What I'm saying here is this, okay? I'm going to take my rotator, I'm going to call it a rotation, and I'm going to get control rotation. So instead of me getting control rotation every time, I'm just saving a reference to it in rotation. So this is kind of like me saying get control rotation. That's the same node, right? Then the yaw rotation is, what I'm doing is, I'm creating a new rotator called yaw rotation here, right? And I'm passing in the rotation yaw in there. So what this is doing for me is it's doing a lot of heavy lifting. Instead of having for me to do this every single time, which is what I'm doing, I don't have to do this. I don't have to expose those pins. I can just get it right from the rotation. All I'm doing here is exposing the pins that I would normally have in blueprints. Okay. The forward direction, I'm going to be using a new vector called forward direction, and I'm going to use the rotation matrix, and I'm going to pass in the yaw rotation object right here, and I'm going to get the unit axis on the x. So what this is basically saying, look at the x-axis and get the vector, get the right vector is what this is basically saying. Okay, and then this is the forward vector. And then right direction is, okay, get the unit axis and get the y axis. Well, this is the right direction. Okay, that's what that is. Wonderful. So once I have those two things, then I make two new add movement inputs, one for the forward vector and one for the right vector. Okay, and that's really how it is. Nice and easy. Okay, so that is basically the same thing that we did. It's a little tricky to program. Like if you had to do this by yourself, you'd have to look it up. Okay, that's why I've included it here. This is just a pattern that we're using. So I'm just showing you what this looks like. Look, okay, it's very similar. So the look is right here. So just like we did in blueprints, I'm just going to copy in the look rotation here. And the look rotation, again, it uses the value. It's a 2D vector. It's using the mouse to go forward, left and right, up and down. And I'm just going to add controller yaw input and add controller pitch input. These are the exact same nodes that existed in blueprints. Okay. Interact, attack, and dodge. We don't have these yet. You and I are going to program these in future lessons, so we can leave these blank. But I do want to take care of run and stop running, and I've added them in here for you. So stop. So running is I'm going to get character movement, right? And I'm going to say, if character movement, I could also do something like if character movement exists, then change your walk speed. I could make a if check. By the way, it's not a bad thing to do, right? Like for example, I could say something like this, guys. If get character movement, I could do this, right? This if check is basically a validation step. That's what it does. Checks to see that the character movement has actually been added. Because if character movement doesn't exist, then this would really fail. So why would I want to do this check? I don't do this in the PowerPoints, but why would I want to do something like this anyway? What if I inherited this and something that I inherited didn't have the movement component somehow, right? That would be bad and they would fail. That's why. So same thing goes with this one. So I'm going to do the same thing with the walking one. I can just say something like if get character movement and then max speed is 150. There we go. So that's everything. We've kind of added everything in from the PowerPoint. I know it wasn't exciting, but instead of me slogging along and typing it by hand and you trying to catch up with me, I put it all in the PowerPoint for you so you can try it out. Okay? So save all. And then what I'm going to do here is now this is the test, the real test. Let's see if it works. Control F5. So does it build first? That's the first thing. If it doesn't build, you've missed something. That's the first thing. So make sure your project can build. The project needs to build. Okay? After it's built, and we're going to take a short break soon because I can get coffee and make you guys, have a break as well. After it builds, there's 2 steps left. We want to first get rid of the camera boom and the camera that already exists because those are going to clash, right? So into my character, if I go to my blueprints, I want to go to my character and go to my BP underscore main character here. I'm going to double click, and inside there, I want to go to my camera boom and player camera and delete them. Please make sure you delete these things here, okay? Because we already have them. We're defining them in C++. We don't want to do this again twice, so we delete them. Okay, compile and save. Then, and only then, do you change your parent class from character to main character. The way to do that is to go to class settings and pull in main character, okay, in class settings. Once I've done this, compile and save, you'll see your camera and boom camera come back. You can check this in the viewport. They do exist now again. This is a good sign that everything is working fine. Next, we have to kind of connect our project with all of these inputs. You can kind of filter for input like this, and you can see that we have all these inputs we have to add in, these manual references. Let's do that. So TPP context, we're going to use that one. Move action, right? IA move. Look action, IA look. Right? Jump action, IA jump. Interact action, IA interact. We don't have a thing for that yet, but we will. Attack action, IA attack. Right? Dodge action, IA dodge. And finally, run action, IA run. There we go. Okay, compile and save. And before we test it, I want to go into my event graph and I want to disconnect, right, all of these things. So disconnect this one and this one. All these execution pins should be disconnected, right? And all I'm doing here is proving to myself and to you that C++ is working properly. I've just disconnected all this stuff, right? Compile and save. There we go. Later on, we're going to clean this up and get rid of them all. We don't need any of this stuff anymore, right? Because it's all C++ driven. And if everything goes well, and if I press play, now we should see the same exact movement that we've seen before. And you can see, my friends, that everything's working right from C++. And I don't need the blueprints anymore, right? I'm so confident, in fact, I'm going to go to the main character and delete everything, like all this stuff right here. This is optional, all right? So I'm going to delete all this stuff right here. Delete, look, delete. That's how confident I am that it works, right? Prove it again to yourself. Compile and save, right? And test it, and you can see that everything works just grand, right? No blueprints, okay? Wonderful. Let's file, save all, exit from the editor, and I'll put this up on DevOps. I know it was a big one. We could have made little other commits, but I'm pretty confident this is going to work. So I'm going to say git at dot, git commit -m, and we'll say converted blueprints input to C++. It's kind of a big catch-all, and I could have done more commits here. Git push. So here we have everything that we've just done in one beautiful little commit, right? And we can always revert back to when we didn't have any of that stuff. Let's take a short break. When we come back, I'll talk about what you need to do for you, right? All right. I'll stop recording.